Hello and welcome back. In 3.2 we start our work on truth tables. And we will go over just a few of our logical connectors. So look at the negation, conjunction, and disjunction. So remember, a statement is either true or false. So for example, if my statement P is the car is gray, as far as truth tables are concerned, there's only two possibilities. Either my statement was true and the car is gray, or my statement was false and the car is something other than gray. If I want to look at the truth table for the negation, we'll stick with our previous example. Then the truth table for that is P, two possibilities, either true or false. So not P would have opposite truth values, so false followed by true. So if we have one simple statement, we have two to the first or two rows. It's either true or false. So now we'll move on to two statements. So P will be still the car is gray. But statement Q will be the car has an automatic trans. Now, there are more possibilities than just true or false now. So we're actually going to need two columns, one for P, one for true. So maybe both statements are true. Maybe we're looking at a gray car that has an automatic trans. But maybe we're looking at a gray car that does not have an automatic transmission. These are the only two possibilities for starting with a true statement. Then we'll look at what happens if we start with a false statement. Well, maybe we have false then true, false followed by false. So this is the basic table that we'll see if we have two simple statements. So 2 simple statements, 2 squared, 4 rows. If I wanted to negate either of these, again, I just go back to the original and flip truth values. Or I could negate Q, which would give me alternating false then true. So just go back to the original and switch the truth value depending on are they talking about negating P or are they talking about negating Q. So next we'll look at a conjunction, an and. So P will say there is snow outside. And Q, this is a calculus course. So remember, statements can be true or false. So if I want a truth table for there is snow outside and I'll write out the word and this is a calc course. I'll have to start with my original table of true, 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 false, false, true, false, false. And then I'll make a third column with P and Q. I should leave a little more space in between there. So P and Q. Think of the and back in our set theory days. It had to come through on both or it was false. You can also think of talking to little kids. Little kids know more logic than we kind of give them credit for sometimes. If you say after school we're going to go to the park and we're going to go to a movie, if you went to the park and to the movie, you're going to have an okay day, like most likely. But if either part is false and you said and, if you said and it didn't come through on part of it, you're going to hear about it from that little person. If you didn't come through on either part, of course, you're still in hot water with the little one. So for the end result to be true, both components have to be true for a conjunction, for an and. Anything else is false when you're working with an and. So next, let's try one that combines both the conjunction and a negation. So let's draw one for not P and Q. So I notice I have two statements, so 2 squared, I should have 4 rows of my truth table. So I'll always start at the same when I have 2 statements, the 4 rows. Both of them true, first one only true, second one only true, and both false. Always in that order, that sequence. True, 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 false, false, true, false, false. You'll do a lot of practice, you'll get to know those cold. So first I'll have to find a not P column. I'll go back to P and switch my truth values. This was a true, now it's a false. This was a true, now it's a false. This was false, so the negation must be true. So then we put it all together. We already have the Q, so not P and Q. We're putting these two together with the rule for and. So remember, the only way for an and to be true is if both pieces are true. So the not P knocks us out of contention for this, so the conjunction is false. Missed on both of them, this is false. Here we have something that is true, This time Q knocked us out. So we have one true part for not P and Q. So there is not snow outside, and this is a calculus course. Would be true just for these original conditions. False of snow outside, true for this being a calculus course is the only way for this compound statement, not P and Q, to be true at the end. So I'm going to have you all try. Let's see. So I'll have you translate and make a truth table. Not P and not Q. So P is going to be the roads are plowed. Q will be drive home will be less than 30 minutes. So see if you can translate the compound sentences and make a truth table. Pause it if you need to. Welcome back. So the translate, not P and not Q. So not P, the road is not plowed. Conjunction, so and, not Q, the drive home will not be less than 30 minutes. Now, as far as our truth table, it's always going to start the same if we have just P's and Q's. True, 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 false, false, true, and of course, false, false. And again, you'll get to recognize that sequence and be able to do that in your sleep after you do a couple of these problems. So this time I need both tools. I need a negation of P. So I go back to the P column and flip truth values. I'll also need a negation of Q. So that would be false, true, false, true. And then we are going to put those two together with an and. I'll make that a little neater. So not P and not Q. So again, with this conjunction, we need both parts. For our end result to be true. So row 1 is definitely completely out of the question. Now I'm only concentrating on the not P and the not Q columns. Not P knocks me out of being true on row 2. Not Q takes us out for row 3, but the final row was true for both of them. So false, 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 true is our end result for not P and not Q. So next we'll look at the disjunction, the or. And again, I'm going to ask you to picture talking to a little kid. Only this time you wised up a little bit. You didn't say we're going to go to the park and to a movie. This time you said or. So after school we'll go to the park or we'll go to a movie. If you went to the park, you still told the truth. You said we'll go to the park or the movie. If you go to the movie, you still told the truth. You said park or movie. If you came through on both, hey, that's great. However, if there was no park and no movie, you are still going to hear about it. So on this one, false, false, is the only way to create a false. All others are going to be true. So we'll start with just a basic P or Q. So take a moment and fill in the appropriate number of rows for P and Q, and then unpause it once you have those first two columns filled out. Welcome back. So hopefully you have true, 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 false, false, true, and false, false. Disjunction, or remember that is our little symbol that looks kind of like a V. So here we took the kid to the park and the movie. We have a happy kid. As long as we said or, we still didn't lie if we just went to the park. As long as we said or, we did not lie if we only went to the movies. But here, if we didn't go to the park, we didn't go to the movies, we did give a false statement. So false, false is the only way to make a false. So now we'll do one more with a little bit of a multi-part thing, and we'll just break it down into sections. So we're going to make a truth table for the negation of P or not Q. So I'll always start with P's and Q's when we have these two statement compound ones. True, 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 false, false, true, false, false. Inside the parentheses, I see I have one negation, so I'm going to make one column of just not Q, which will switch all four of those truth values around from column Q. Moving out a little bit more, now I can get together the entire compound statement within the parentheses. So now, and I'll just kind of highlight this one in red, P or not Q, I'm concentrating on these two columns at once. I'm working with an or this time, so the only way for me to make it false is if both of these are false. So row 1 is true. Row 2, I came through on both of them, true. Row 3, that's the only way I can miss. Both of them are false. Conjunction is, my apologies, disjunction is false. Here, it's a disjunction, it's an or, so as long as one part is true, the whole thing is true. Just like our union work back in set theory, if it was in just one part, that was okay with us for the union. We got to keep it. So my last column then, I'll simply flip the truth values on the previous. So I had true, true. Now I have false, false. I had false, true. Now I have true, false. So this is then my end result. It's true under just one set of circumstances, that being the original statement for P is false and the original statement for Q was true. That would make this compound statement true, and that would be the only way to make that compound statement true. So next we look at what happens if we have three simple statements. Well, when we had one simple statement, 2 to the first, to the first rows. 2 simple statements, 2 squared or 4 rows. So 3 simple statements, 2 cubed or 8 rows in our table. So we'll create one for a table for, what do I want to do here? P or not Q and R. So for this one, I'll need 3 initial columns, a P, a Q, as well as an R. Now, as long as you know your initial table for the 2x2s, you don't have to memorize a new one. You're just going to slide it over a little bit and draw your little 2-statement truth table. True, 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 false, false, true, false, false. And in one set of circumstances, you're going to slap trues in front of that. Then you're going to make the table again, this little 2-statement truth table. True, 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 false, false, true, false, false. And what do you suppose we'll do in front of those? Sure enough, the only other possible truth value, maybe they were each preceded by a false. So you don't have to memorize a new table for the three simple statement truth tables. Just take your previous one, put a true in front of it, repeat it with a false in front of it. So all you have to know is this much of it: the true, 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 false, false, true, false, false. After that, you're in business. You've got everything you need. Okay, so looking within the parentheses, I see I have a not Q, so I'll create a not Q column. So now I'm just going to look at the Q column and switch those truth values. So it looks like I'll have 2 trues, 2 falses, 2 trues, 2 falses. So now it'll be, instead, for the negation, 2 falses, 2 trues, 2 falses, 2 trues. Next up within the parentheses, we have our disjunction, the or. So P or not Q. So again, on this one, I'm concentrating on the column with P and the column with not Q. I have an or, so if any part of it's true, the whole thing is true. So that gives me the first 4 as freebies, just from looking at the P column. After that, let's see, row 5, I have a pair of falses. Okay, that's false then. Row 6, same problem. Rows 7 and 8 are saved by the not Q. Both of those will now be true since we have an or. Okay. So now I'm ready for the whole thing. P or not Q, and with the R. So now I'm looking at, I'll do this in blue, the R, and the parenthesis stuff. So just the 2 blues. Pay close attention though, this one is a conjunction, an and. So this time the only way for me to write a true is if both are true. So row 1, okay, both are true, I'll keep it. Row 2, R throws that out. Row 3, okay, both of them are true. Row 4, R again shoots us in the foot. Row 5, now it's the parentheses part that led us astray. Same thing with row 6, we have another false there. And let's see, row 7, 2 trues, we're okay. Row 8, a true and a false. 1 false makes the whole thing false when you're working with an and. So the only trues were the true, true in 1, 3, and 7. So let me have you all try one out. So we'll create a truth table. Negation of the quantity P and Q, close it up, or it with R. So go ahead and pause it if you need to. Unpause when you're done. Welcome back. So we have our 3 columns, P, Q, and R. That means we'll have 2 to the third or 8 rows. And again, you don't have to memorize all 8 rows. You just have to know the 4 rows from the little guy. So true, 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 false, false, true, false, false. Slap a true in front of those 4. Then make that table lower again, but put a false in front of it. So, true, 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 false, false, true, and false, false. Each of these preceded by a false. All right, so I'll start with the stuff in parentheses, P and Q. So an and, the only way for an and to be true is if both pieces are true. So row 1 and row 2 both look good. Row 3 and 4, not so much from the Q's being false. And rows 5 through 8 are also false. As soon as I see the false in the P column, I don't even really have to look at what's happening in the Q since I have an and I need both pieces to be true. So next up, we will negate that previous entry. So remember, negating something changes the truth value. So our first 2 were true, now they're false. The last 6 were false, now they are 6 trues in a row. Now we're ready to do the whole thing, the negation of quantity P and Q or R. This time we're working with an or, so if either part's true, we're happy and we'll keep it as true. So just to kind of highlight where we're looking, we have this last negation we worked with, as well as column R. And again, if either part is true, since we're working with an or, the whole thing becomes true. So thanks to the R, row 1 is okay. Both of these are false, so row 2 is false. 3, we're good to go on both of them. 4 is true thanks to our compound statement on the left of the or, and all the rest of them in fact have trues for that part, and we're working with an or. So if even one part of it's true, the compound statement is true when we're working with the ors, with the disjunction. So in this one, there's only one way for us to make this compound statement end up as false, and that's if my first 2 statements were correct and my last statement was not true. All right, so some problems I would recommend trying out in section 3.2. I would try 1 through 4 all and 5 to 67 on the odds. If you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.